Okay, so hi everyone. It's good to be back again. This wonderful session. You guys solving business problems with SQL, and we had our first session 2 weeks ago, and it's good to be back again. If you are currently on the call, you can just signify by dropping your name and also just say hello in the comment section. Yeah, so I'm going to start in a bit. So let's just give it about 5 minutes. I'm going to kickstart this episode. Just going to continue from where we stopped in the last episode. Uh, excellent, excellent, excellent. All right, all right, all right, all right. One more minute. Let me just, while we wait, let me just run through uh, last week what we did, what we are doing, what we are doing. Uh, so we were discussing solving an e-commerce problem. So we have a sample data that we're working with, which already provided link to where we can get the data from the first video live session. And I kind of provided the schema of data in this notebook. And I think I also provided the uh, like a GitHub repo for this notebook so that you can also have access to that. So now this is schema of the data we're working with. It's an e-commerce data, and we're going to look at an overview of what data is about. So the schema of data is shown as below. Invoice number, that's the identifier of each transaction. The stock code is more like the product code for each item that uniquely identify the product that was purchased. And also we have description that gives like a product description, and quantity that shows the quantity of such products that was sold for that particular transaction, that is invoice in that case. We have invoice dates to show the dates that the invoice was made, and you have unit price, which shows the price per unit of that product. So how much is 1 unit of that product? Then we have the customer ID associated to that particular transaction so that we can identify which customer made that purchase. Then we have the country column, which is the country from which the order was placed. And we did customer segmentation, product performance analysis, and I think we also did churn prediction in the previous session. So we achieved these three using SQL, and in today's episode, we are going to wrap up with sales trend analysis and customer retention and lifetime value. So we're going to get started in a bit. In 2 minutes, we're going to start. Uh, just do a run through of what we did, also the queries that we ran last week, then also go to what we want to achieve this in this episode. All right, so we should be getting started in 1 minute. 1 minute, 1 minute, 1 minute. 1 minute is about to go. So we're gonna get started. All right. So as I said earlier in the last session, we just going to like gone through and some of the libraries that we used in the previous session, of which we are probably going to make use of it, is the pandas library and the OS library. The OS library is just a library that we use to work with the OS that you are working with, uh, which is the depending on the kind of system you're using, whether it's Windows, whether it's Mac, right? So which depends. So now we are going to then do a run through. So pandas, which is a library that is used to read data as data frame, whether it's Excel, whether it's CSV, right? We are going to be also using that. So in this particular cell, we use the OS uh, library to set a working directory, right? We use the OS library to set a working directory. Right? So so after setting the working directory, which is where uh, the data is located, right? We use pandas to read it into a data frame and call it df. We check the shape, which tells us number of rows and columns. So we have about 541,000, over 541,000 records with 8 columns. And these are all the 8 columns that are there. Yeah. So df.h shows the first 5 records in the data, and those records. So we went ahead to kind of convert the invoice date to a date time to more to like a date object. And after doing that, to check the info, what the data is like, we have the invoice number, which is a string object, stock also like that, quantity is integer, then invoice date, since we are converted to the date time, is a date time object, finish price is float, customer ID is float, country is string. This customer ID can be string also, so this float might not be necessary, right? Then we use this SQL Alchemy library and use the create engine module in the SQL Alchemy library to establish a connection to a Postgres database. We want to save the data into a Postgres DB, and we are using get pass in order to get our password, in order to input our password. And the reason we are doing that is that so that when you are inputting the password, it doesn't show up on the screen, so it gets encoded on the run. So that's why you are seeing start dot here, right, when it is being run. So let me just start running the code from here actually. So import pandas. I don't need to run the other code where I am storing the data to Postgres because I already done that. So here it will request for the password. I put the password, right, and then I will then save the data to what, to the connection that I already set, which is this connection here, this connection string. So connection is equals to engine, the schema that I want it to go to public schema. I don't want the index of the data frame to be stored. I want it to be stored in chunks of 100,000, and I want to be able to do multiple inserts, right? And if you run it, it's going to show number of records that was loaded. This is 511,909, which should correspond to this. So you can know that all the records was written to the database. So now, having said that, we now went further to do our customer segmentation, right? So, and the question is, in this case, is what's the breakdown of customer purchasing behavior in terms of total revenue generated and total orders placed? How can we segment customers into different tiers based on spending? So, we use this query. First of all, we try to like identify the for each customer, we did a count, the number of transactions, like the number of orders, and a sum of their transaction, which is units price times quantity. Units price is how much each product is selling, and times the number of products the person bought will give us an idea of what is the total amount that was paid for that particular product, right? By the time we sum everything up, it gives us the revenue that was generated for that transaction, and we are aggregating everything at customer level. So we can see the revenue that customer has generated from inception to date, and we are ordering the aggregation by the revenue followed by the quantity. That's the number of orders in this case. So, and we run the query as this. So let me just run it. Uh, so run the query and give us, these are the top 10 customers in terms of revenue, then followed by number of orders. So you can see that when we are doing the ordering, we first of all consider the revenue before we consider the number of orders. That's why this person is at the top. If we were considering number of orders, probably this person would have been at the top, right? So that is that. On that note, just to have an higher level of the revenue that we have generated from those customers. So now we want to now go ahead and do something interesting. So we want to now take, for each customer, count the number of orders, sum the units and quantity, right? Get the revenue, and we are now doing something, say the revenue divided by the number of orders as average revenue per order. Now, so we are getting another metric. So that is like when you divide this value by this 77, what it gives you is this average revenue per order. Then we are now streamlining it to only people that have generated up to 15 orders. So you should not just consider somebody that they are probably generated one order or something. So the minimum we are considering is 15 orders. It might depend on the business what they want to also consider in this case. Now, in this case, we are now ordering by 4. We are now ordering by 4. That is the average revenue per order in this case. And if we use that metric to judge the order, this customer is the one that is now coming first with 123,000 in terms of revenue, and the number of orders is 26, and the average revenue per order is 4,758. It means that on the average per order that this person has generated, person has spent 4,758. Right? If you use to consider this person spent more in terms of revenue, which is 279,000, but in what, how many orders? 77 orders. But this person generated 123,000 in 26 orders. And even if you double this figure, it's going to be around the same. It wouldn't even be up to this guy, but it's going to be around the same figure, right? Which is about 246. And if you double the number of orders, that's 52. So it means the person will have generated 256 in terms of revenue in 52 orders, compared to the person who would have generated 279 in 72 orders, 77 orders, which is still far, right? So we are now considering using the average revenue per order to now do the threshold in combination with the minimum of number of orders generated by that customer. So that's what we did here. And what did we do here? Okay, here we are trying to check the recent invoice, the latest invoice that we have in data set, and we had September, no, 9th of December 2011, right? So we want to now check pattern of purchase for previous month, right? So what we now did is to now check for the month of November. So the month of November, so we want to check the distribution of purchase. So for the month of November, we add this distribution, right? This is the revenue generated per customer for the month of November. I will now do the describe method on it and see, okay, we have about 1,712 That's, we have already aggregated by customers. So if you have 1,712 customers that generated orders, right? And the sum cannot be here. So but in terms of the minimum that we have here, we have minus 295. I don't know why that came about, like that negative orders, maybe in terms of discount or something like that, right? For a particular customer, we have minus 295. The highest that we have had in the month of November is now 329,000. That's the highest number of orders that we've gotten in December only. But is this not weird, right? Maybe it is not, maybe because of the negative figure. Because the reason I'm saying that is uh here when we aggregated by customer ID and ordered it in descending order of revenue, the highest we had is 279,000, right? And here you are having for the month of December only to be 329. So perhaps because of the negative figures, that's why you're having this. So this is the distribution here. And the reason we are doing this is because we want to create some form of segmentation, and we want to do it in for a particular month. And the reason is that we don't want a situation whereby we want to now segment customer based on all time transaction. It's going to be unfair because some customer will have been in the business for like 5 years, and some customer have just started doing business with the company maybe 6 months ago or 3 months ago. So we want to do it on a monthly basis, right? So we want to consider the recent months in this case. So now, but if you look at this distribution very well, like majority of the data is not even up to 1,000. Like you can see here, 75%, that is the 75th percentile is 642. Because so you know that this guy is even an outlier. 25% of the data is 199, 50% of the data is around 352, 75% of the data is 642. So this guy is an outlier compared to every other person there. So now we want to now classify based on this set of segmentation. Now we did class one is someone that has done between 0 to 200, and then 200 to 300 is class 2, etc., 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 like this. So we did that segmentation that way. So what we did is that we used CTE to now write the query properly. So first of all, we aggregated the revenue generated per customer in the month of November 2011. That's what we are doing here. Then we now did the segmentation. So if it is less or equal to 200, then class 1. So definitely this one can be, I'll put it as below or 200. Let me just put it that way. That's the appropriate way. So now then do the classification this way, and we have this figure. So if it's above 1,000, then so the people in class 05, which is above 1,000, about 222. People in the lowest pocket is 429, like that. All right. And the people in the middle class are 454. Those are probably the highest in that segmentation, the highest customers. Now, we do product performance analysis, questions which products are mostly frequently purchased together. What are the top 10 products that generated the highest revenue, and how does that change per country? So what we did is to do like a self join on the table, and we want to kind of know which two products, right, are purchased together. So what we did is do a self join between the table and itself. As you can see that we are joining the two same tables, right? On invoice number, if they have the same invoice number, that is very important. If they don't have the same invoice number, because that has to be in the same invoice, that's the same transaction, right? And if the person probably, when the person purchased product A, probably the person also purchased product B. Let's find that kind of combination. We go to another transaction and see, and we now see for all those transactions which were the common ones, right? And ensure that the stock code in the first transaction is not the same thing as the stock and as the product in the second table that we are comparing side by side. We have to compare products within the same transaction, right? So, and ensure that the stock code are not the same, less than each other. So when we did that, we also ensure that we go by 1, 2 and having count star greater than 1. So we want to do a count between those two product combination and ensure that we want to limit it to the one that has more than one count, definitely, because if the combination of those two products just occurred only once, it does not make sense to say that they are frequently purchased together. Frequently has to be more than one, right? At least more than at least two. So order by 3 descending down, and we found that these two combinations are common: 2697 and 22698. They are the highest in the table with 905 times. So with this, the business can make a decision that okay, people that usually buy this product 22697 will most likely get 22698. It's also vice versa, right? Since if you get 22698, you most likely get 22697. And if you also get 22697, most likely get to 22699. So these are, you can see they purchase them like many times. Look at this. 905, the 10th one is 654. And how we will have more, we just limited it to 10, right? Which is quite interesting. Top 10 products with the highest revenue. We are using this product code as usual. We saw that dot is one with the highest revenue, 206,245. And this dot is not part of the combination that I bought the most. But let's see this one, 22423. I don't think that one is here. 22423, that one too is not here. 47586 is also part of the highest products with highest revenue, etc. etc. The minimum we have here is about, in the top 10 list is 53 over 53,000, which is product 79321. Okay. And we also have top 10 products with the highest revenue and how they differ by country. So what we did here is, first of all, we group the revenue generated on each product for each country. So in each country, what is the revenue generated for each of those products? So go by the country and stock codes. Then we now ranked those products for in each country. That's why we say partition by country, but order by the revenue in descending order. They will now filter where the rank product is less or equals to 10. And this is the ranking. So Australia came, first of all, looking at Australia, we now have the rank 1 to 10. You see those products like that. Then this is USA, 6, 7, 8, 9, 10. Like 1 to 5 is still there. It's just, it has been removed from the list because it's a lot of data. We have about 379 records. So this result has been truncated. So that is by the way, but this shows the whole ranking of products from first to 10 in each country. All right, then next we talked about churn prediction, and this is to understand how customers have stopped transacting. Right, this might be the definition of this can differ for many organizations or businesses, right? So our customer have stopped. So it might be a 3 month something, it might be 6 months, maybe in telecom now. Telecom, they can have time like inactive customer. They can say inactivity is after 6 months. After somebody has been dormant for 6 months, so say that person is now considered inactive, right? You hear terms like that. But for churn can be each person did a transaction last month and the person did not do this month at all. This is already 29th. You can say that customer has churned or stopped transacting, right? Depending, it might also differ per business. In this case, we are considering customers that have stopped transacting between July to December 2011. So that's what we are considering in this case. So what we're now doing is that, okay, before July, who are those customers that have been transacting, right? We now want to know those customers that have been transacting before July, if they were now not transacting July for going forward. right? In this case, July to December, which is the recent date. So first of all, we identify customers that have been transacting in the month of before July 2011. Then we now found those customers that are also been transacting for the term period that we are considering, which is July to December. Then we are now doing a left join on those people that have been transacting before July and those that have not been that have been transacting in the term period, which is July to December. So whenever the whenever the uh, customer, so we now did a count and do a case run on it. So if I'm doing a left join on people that have been transacting before July, right, on the people that are transacting between July to December. So whenever there is no customer ID from this before July inside this term period, it means that person has stopped transacting. So those ones that are common in these two are those guys that have been transacting before and are still transacting. But those guys that are here inside this before July but are not found here are the ones that are strong. So we now did count of A1 dot customer. A1 are those guys that have been doing before July. So we call them transacting customers before. Now, when A2 the customer ID is null, that is when there is no common customer ID between A1 and A2, then those guys are churn customers. So then we are counting those guys from A1, which is before, as churn customers. And we also now we also want to find the percentage of those guys that have actually churned. So this is the result. So out of these 3,000 customers that have been transacting before July, 977 of them have stopped transacting after. That's about 32% of that population. So with this, customized campaign can be sent to those customers to win them back into the business. So that is where we stopped in our last series, right? And you can go back to watch the video to get more context. So in this case, we did demography of the highest churn. So we classify those churn customer into country and see the demography. So that 885 were from UK, and that's not a surprise because the company is UK based, so you should expect that figure. But we saw that these two, 18 and 16 of them, were in France and Germany respectively. All right, so let's go sales trend analysis, which is the next thing, and customer retention and lifetime value, which is the last thing for today. So for sales trend analysis, so this is the question here. So what are the monthly sales trend over the last 2 years, and how do seasonal variations affect sales? Can you identify months with unusual spikes or dips in sales? So this is an interesting question, and since it's strictly monthly, so it means that if you want to analyze this, you have to analyze it on a monthly basis, right? And to identify seasonal variation, since it's monthly, classify them into maybe winter, summer, spring, whatever I want to classify them into, right? Or first quarter, second quarter, third quarter, fourth quarter, irrespectively, right? Just to understand how those trends are. So we can actually try and do this. And can you identify months with unusual spikes and dips? So I think one query can answer all of this in together. All right, so let's get to this. So let me just copy one query up here and just edit it to suit what we're trying to achieve here. So let me come to this part. Let me pick it from. I'll just pick this one, this query here. Let me just copy this one. All right. So let's go to our sales trend analysis. Now, what are the monthly sales trends over the last 2 years? Okay, let me just put this question here and blah 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 blah. All right, so let me put it another line. All right, for the monthly sales trend, so definitely you have to classify the sales trend into months, right? I'm gonna do this. So I will say monthly revenue. I'll call it sale with monthly revenue. We don't know about uh uh city common table expressions. This is how to write city using the with statement. So with monthly revenue as select this how should we go about it? So let's go about it this way. You know we have invoice date. So let's cast it as first day of the month. So for the invoice date, let's cast it as first day of the month and group it that way. So since we are using Postgres, how do we find first day of the month? So let me just check that out. First day of the month, first day of month. Uh, then we sum the unit price and quantity, right? Then go by month. So go by one. Then after that, I think that will be it. Then we can then classify into whether first quarter or something. So yeah, we can then do that. Should we do it? Uh, you can do it everything together. So first day of month. So first day of month in Postgres. Okay, I think I can use date trunk function, invoice dates on the invoice date. So we say date, date trunk, date trunk, invoice date. Once truncate date by month, uh, then the dates column is invoice date as invoice. Let's call it as invoice month. Uh, invoice month, and we can then also find the quarter. That is, let me cast this invoice it as date, just to be on the safer side, right? Because it might not just function properly. So, uh, should we do quarter? Should we do quarter? Right, let's do quarter. So, let's do quarter. We say extract quarter um as invoice date as date, invoice date this way as date. Let's put it as invoice quarter, invoice quarter, uh, some blah 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 blah. Okay, so go by one. Uh, then select start from it. Select start from monthly revenue. We don't need all of this guy. So let's look at what it looks like on the file column. Date, trunk, month. Okay, I have to use single quotes. It's taking that the column. So let's do that again. Didn't I? Oh, go by 1, 2. But I'm using two this in there. All right. All right. All right. All right. This thing is giving it extra this thing there. But that's fine. Let's order by the month. Order by one. Yeah, let's order by the month. All right. So order by month. Order by month just works. So I think the first sales was in November 2010. Then this December. This is picking it as, but that's fine. Why is it picking December 2010 as first quarter? That's weird. That's weird. It's not supposed to work that way. Uh, it's even not picking it as first day of the month. That's one of the problem I'm having here. It's not picking it as first day of the month. Uh, Let me use formats. Is the date format? I think that would be the easiest way to go about this. To chart. Let's go with this guy. But I'm not comfortable for the fact that the way it's extracting the quarter, from the invoice date. Okay, we can find a way around that. So let me use date to char the dates, and I'll specify the format I want it. Uh, to char year, month. Let me just do it this way. It's enough. Then for the quarter, maybe using a case when we just do. So uh mm, okay, I think using a case when we just do. Let me see this first. Extract month, extract month. Then I will now format it the way I want. Wait. There's 10, 12. There's supposed to be 10, 11, right? There's supposed to be 10, 11. 10, 11 is missing here. Let me see whether this thing, maybe I'm the one that is saying it another way around. That's weird. Let me change this back to quarter. Let me see. Quarter. quarter. I think that hopefully works the way I want it to. Okay, I think it's the casting of the dates that is making it look somehow. This first quarter is correct. Second quarter, all right, that's correct. All right, so I think it's okay in this format. And mm, 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 mm. Let's say cast this as date. Let's see. Let's now cast it as date. Hmm. I'll put it at 01 here and cast as date so that it will be first day of the month. Yep, I think that will work perfectly well. Yeah. So that is good. So and how do seasonal variation affect sales? Blah 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 blah. So let's assign this to a variable. Let's call it monthly ref underscore df is equal to this. Then we can now read from it. So we can then further do our we have to visualize it because we cannot kind of see the those trends here. So we can use matplotlib matplotlib dot py import. I think we just did import matplotlib dot pyplot at plt. I think I'm correct with this whole thing. So we can then now do our plotting of a thing, right? So let me see whether I can call a plot x and y and let's say bar. Oh, sorry, and it's equal to bar. So now our x is going to be the invoice month, and y will be the revenue. Let me. So this is what it looked like, and so does it look arranged? Yeah, it definitely looks like it. So this one 2010 to 2011. 2010 to 2011. Let me look at the data, the description above again, just to know that probably we are not missing anything. There's something about the data that I mentioned up here. I don't know whether I missed it. Oh, I didn't mention it. It will have been in the post that I made about the data. But if you also go to where you download the website and the data from Cargo, you see those information there. So you can see the trend, and November kind of had the highest trend, but we cannot compare it to another November, right? We cannot compare it to another November, so we don't have up to 2 years of data here. That's sad. That's sad. I thought it's supposed to be up to 2 years. Let me confirm that. It's supposed to be actually up to 2 years. It's supposed to be up to 2 years. I'm not sure. Oh, it's supposed to be up to 2 years, but but it is what it is. We can see this the data here. It's not up to 2 years. It's just from 2010 to 2011. You cannot call this 2 years. It's just about 1 year data that is here. So that is what it is like. We cannot say maybe there's some kind of seasonal variation. Maybe there is, right, some kind of trend, because compared to like the first quarter, which is about January 2011 up to up to up to March 2011, the on the average, if you look at the growth compared to the second quarter is kind of on the high side, right? If you look at if you look at uh, April, May, June, yeah, look at the bar, if you want to average it out, the bar is going to be kind of high compared to the first quarter. And if you look at the third quarter, which is July, August, September, look at September up here. But you can average it out, like the trend is moving up for each quarter. Then for the last quarter, as you can see, obviously. But this December is supposed to be higher than this, I suppose. But because if you look at the recent data the recent invoice dates that we have, it is the 9th of December. So let's go up and see for ourselves. It is 9th of December, as you can see here, 9th of December. So there have not been invoices were not recorded for that's up to 22 days in December, right? So and that's a lot. So it means that for just 9 days, we recorded this amount. Imagine that we should have 22 days of December added to it with the whole Christmas thing and all. I believe that this should have been better, right? So so definitely the last quarter had more sales compared to every other quarter. So it's obvious from here. All right, so that's on the sales trend analysis part, right? And if you want to also confirm what I just said, you can see it from the chart here, but we can just average that and so that you can see for yourself. So what we're gonna do is this. So I'm gonna copy this so I can see the trend per quarter in each year. Uh, Let me convert this to year and month. Just year, just year, right? Just year. And cast it as integer instead. Integer. Let me call it invoice year. Then invoice quarter. Uh, I think I should just concatenate the year and the quarter, right? Yeah, concatenating the year and the quarter together, right? How do I do that very comfortably? Okay, so this is what I'm gonna do. I'm gonna do this. I'm gonna do this. So yes, since we have already have quarter here, so go by 1 and 2. I think this is just straightforward and just see the results. Uh, yeah, it's not be straightforward. So you can see per year per quarter. Look at it. 2011 first quarter. Let me arrange it by quarter too. 2011 first quarter, we have about 1.7 million. Second quarter, 1.9 million. You can see that second quarter 2011 is more than the first quarter. Likewise, third quarter, 2.3 million, which is more than the second quarter. Then last quarter is 2.9. You can see that the trend is increasing, right? can also visualize that. You can see that the trend is increasing. So this could have been way more, right, if the month of December in 2011 was complete. So that is that on that note. So uh the last thing is customer retention and lifetime value. What is the average lifetime value of a customer and how long do they remain active? And how does this lifetime value differ across different regions? So in this case, we are trying to understand the lifetime value of a customer. And what does that mean? It means that it helps the business to identify key customers, key customers in the business. Let's take bank for example. The way bank makes their money is through mostly through deposits. You might think that because you make withdrawal, they make money from that side too, right? But it's mostly through deposits. Like very important people, and those sort of people just makes about probably 5%. And it's because I've been there, I've worked in that sector before, right? So they make about like 5%. They're very small, right? They don't withdraw just like the general masses that withdraw 5,000, so they withdraw 10,000. You know, their money is just sitting there. They're just using those money to invest, and the bank is making profits from there. It's not from the general masses, right? Those sort of important people, they look at them and analyze the lifetime value. And also in e-commerce, same thing can also be done. So that's why if if some certain people just enters the bank and say they want to like close down their account, the way they're going to treat customer A and customer B is going to be different. By the time you look at the customer lifetime value of customer A and compare to customer B, like if you let customer A go, on average, you're probably going to be losing maybe 5 million per month, something like that, or 10 million per month on that customer in terms of what they're going to be gaining in terms of profits by using that person's money to invest. Compared to somebody that maybe is on an average is 10,000 that are gaining from that person per month. Like I tend to think about it. So it's very important for the business when you're talking about customer lifetime value in this context, right? So uh, in this case, we are talking about e-commerce. And how do we do this? First of all, we do a count. Let's do a count of orders that this customer has generated. So it is done at customer level. That's why it's called customer lifetime value, right? And what is the total revenue that this person has generated from inception to date? What is the first purchase date? When was the first time this person made a purchase? When was the last time this person made a purchase? This is done in order to know the age of the customer, right? So you are you want to pick this from the table, which is this table. Pick this table. Go by customer ID. This customer ID have to put in code because of the way this thing is. The code. Hey, sorry, mistake. Put in code. Put in code. I have to pass this invoice with as date because you might not see that proper date. So just cast it as date. So cast as date. Also cast as date. So last purchase is without customer. Go by customer ID. Let me alias this as customer ID. Okay. Then now the customer lifetime value. That customer. So on top of this layer, right? You are picking the customer ID, you are picking the total orders, which is this, you are picking the total revenue, which is this. Now, we want to now do the date difference in months between the first purchase date and the last purchase date. So, how many months are this customer been with us? Plus one, plus one as customer life span in months. As we are doing a monthly CLV here. Total revenue divided by total orders. That's more like average revenue, average order value, average revenue per order. Then we are now doing total orders, that is total number of orders that the person has purchased, divided by the month, the age in month of that customer, purchase frequency per month. This will tell us the number of times this person has will make a purchase on an average in a month. So then on top of that, we are selecting everything that we have calculated above. And we are now doing the CLV, which is the average order value times the average order value, that is in a month. What is the average revenue that this person is going to give us in a month on average, multiplied by the purchase frequency per month, which is this guy that we did here. This purchase frequency per month, that is on a average in 1 month, will this person shop? Is it 3 times? Is it 5 times? So I did average order value times that month, then times customer lifespan month. That is that's the number of months that this person has been shopping with, that this person has stayed with us. We are now calculating that as CLV. This means that for the whole period that this person has stayed with us, on an average, this is the amount that we have gained from this person on an average. So it means that we are going to lose that customer. This customer is not going to be with us for 1 year or for 5 years, depending on the customer lifespan per the customer lifespan per month. You know that this is what you are probably going to be losing from this person. So now, uh, if you run this now and then run it on the by column, month does not exist. Okay, let me put in code. I'm not sure. I have to confirm that this function does actually exist in Postgres. Okay, I think it's date underscore diff. Let me try it again. I think it's date underscore diff. So let's see what the problem is this time. Function date diff does not exist. Okay, so let's see how else you can do like date difference. Date, I think you can just use minus or something, but that will now depend. What I'm seeing is kind of what I'm seeing is kind of. I just want to ensure that we are using the right, whatever we are using to calculate the month is is uh is what we are supposed to be using, right? So definitely let me just do something like this. I just want to ensure that we are using the right, well, anything that we're using is working the way it's supposed to work. So let me call query is equal to da, da, da. Pick the customer, pick the Let me just pick the dates because that is what we're trying to look for here. Group by one. And if we do if we do this pd.sql, then query comma engine, this will give us uh zero read underscore SQL rather. So this will give us, okay, for each customer this is the first time, and this was the last time. This person's first time was also the last time. This person's first time was also the last time. So okay, so now to now do the difference, right? So let's call this with customer grouping. Let me just call this customer grouping. With customer grouping as this, and on top of that, we did our age in month to set customer ID for today's star, comma then the age. Uh, let me use what I have here. Extract year from then age function. On the end date is the last purchase date, comma first purchase date, then multiply by 12 plus extract extract the same thing, extract month from this guy, from the age, like this. Look at it as month difference. Look at it as month difference from customer grouping. So let's see what this gives us, and we're able to tell this is 12. This is giving us 12 months. Okay, which is valid for this one. This one is 0 month because it's the same thing. This one is about, this one also 0 months. This one is 8 months. I think it's kind of valid because this is July, so this is January 2011. Then this is October. It's supposed to be like maybe 9 months or so, but then it's not up to 9 months per se, right? So you can just take that as 8 months. This is 11 months. Okay, I think that works. So now we are going to use that so as our month difference. So we are going to use that to calculate our let's put it here. That would be customer lifespan month. Okay, we're going to use that here. First purchase, blah 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 blah. 3 plus 1 there. Let me see. Is there a reason to put plus 1? This is December. I think it's good that way. Just to be, it's good that way. So that, putting it here will give us the customer lifespan in months. I'm going to put that here. Have I not? Yeah, customer lifespan in months. Uh, so that will solve their problem there. Then every other thing here follows, right? So let's read the query again. Customer lifetime value. Let me customer life LTV. Undefined column. What month does not exist? date diff. Okay, I have to also copy that this h something there. I have to put it here. Yeah, and I have to put everything together here. And put inside brackets. Bracket space. I think it should be good to go now. Division by 0. Oh yeah. So since we have case whereby a 0, uh, let's use the code to resolve that. The code, the code, the code, the code when it is 0, then put it as 1, else put it as itself. All right, I think the code should work. Let's see. Oh, we can use the code. Oh, interesting. Uh, uh, I don't want to use case when. The code. I guess we're going to use case. So we say case when. Be case when this is equals to 0. Then this else else this and end it. Did I put it inside brackets? I remove the bracket. Let me put this bracket here. Let me see whether the bracket is complete. I think yeah. So let's do that once again. Where did I put the end statement? Then this end is not supposed to be here, sorry. Then this oh, I think I'm even doing, then there's supposed to be plus here. I think this is supposed to end here. So if it equals to 0, there's a lot of bracket that don't come in place here. There's a lot of brackets. So that end here. If this equals 0, then 1, else leave it as the rest here, and then now where would this end? And then it end, and close the brackets, then brackets. I think that solved it. Ooh, that was intense. Okay, so let's filter this one out of it. Where this customer ID is null or something. I don't know. It's not treating this as null, so this one is supposed to be there. I don't know whether it's going to filter it up. We are not considering this guy anyway. So order by CLB. So this is the one, the highest CLB. This person is about 1 million. That's 6 zeros. Yeah, about 1.4 billion as customer lifetime value in 12 months. in 12 months. So in a year, this one it doesn't have a customer ID. So let's consider this person. In 11 months, we are going to be having like about 279,000 in terms of revenue from this person in 11 months. And purchase frequency per month is 7 times. This person is about 20 times in a month, but the CLV is about 132,000, right? But this person is more like premium. Even this person here, because this person is about 7 times in a month, even it's just 7 times, but the person is generating about 279,000 in those 11 months. So with this, you can use to analyze what you're going to be generating from this person. Unlike all these rest of these customers, whereby even in those period that we have these people, it's negative figures, right? So you know how to prioritize your customers in this case. So I think that will be it. That is the end of this particular case study. And if you have any questions, so people on the call that want to ask questions, you can ask your questions now, right? You can ask your question. I can drop the chat. You can drop a chat so that we can answer your question. This is the time you can drop a question. So we have like 5 minutes to do that. So our next case study is going to be on the 6th. It's going to be on the 6th because it's Sunday, every Sunday. No, I said 2 times in a month. On a Sunday, it's on a Sunday, 2 times in a month. And the only far we can put it is 6th. Next episode is going to be 6th, and which is like next Sunday. That's crazy. And uh the next episode after that will be on the 20th of October, right? So 2 Sundays in a month. No. Oh, sorry. Let's make it 13th and 27th. Yeah. The next episode is going to be 13th, and then the one that's going to follow is going to be on the 27th. Yeah. So 13th and 27th of October, that's when we're going to be having our next episode. Yeah, next episode. So that will be it for today. Don't forget to follow the YouTube channel and hit the notification bell in order to get updates on videos that we're releasing. And uh, we also have case study, end-to-end data engineering architecture. I'll be dropping the episode back to back now. Uh, I've dropped like 2 introductory videos on the channel. You can check it out. MDS, Modern Data Stack, and I've introduced us to the